I have to admit, I completely ruined a perfectly good Saturday last week. I was
Mm,
trying to bake chocolate chip cookies, and I swear I ended up with two batches. One was just pale, sad Frisbees,
right.
and the other was basically charcoal on the outside with a raw dough center. It's honestly embarrassing.
It sounds like you were fighting a losing battle with thermodynamics.
That is exactly why I wanted to do this deep dive.
Yeah.
We found this paper from the Journal of Food Science called The Thermodynamics of the Perfect Cookie.
Great read.
Yeah. So we're going to stop treating baking like this, mysterious art form and start treating it like hard physics. The mission here is to decode what they call the heat and mass transfer secrets.
And looking at the data, it's surprisingly complex. I mean, the difference between your sad frisbees and a great cookie isn't usually the ingredients.
It's the architecture.
It's the architecture. You're basically engineering a structure using heat and moisture.
Okay, so let's get into the blueprints. I just shove the tray in and hope for the best. What is physically happening in there?
Well, the paper calls it a biphasic shape journey. Think of it like a two-act play.
Okay.
Act one is expansion.
Right, the puff up. So that's when the butter just gives up the ghost,
Yeah.
around 80 degrees Celsius.
That's it. The fats melt. And at the same time, the baking soda starts to decompose into CO2.
Carbon dioxide.
Right. And those little gas pockets push the dough outward and upward. That's your radius and your thickness.
Okay, so it grows. But then the study says something that feels wrong.
Yeah,
Phase 2 is shrinkage.
it is.
But wait, usually if my cake or my souffle shrinks, I've failed. Why would we want a cookie to collapse?
Because if it doesn't, you're not eating a cookie, you're eating a tiny cake.
Ah,
Once the moisture level drops below a certain point, about 0.10 grams per gram of dry mass, the structure just has to settle.
so that little collapse is good.
It's vital. It packs everything
Oh.
together. If you pull it out before that happens, it's doughy. If you wait too long after, it's a rock.
Rock.
A rock. You need that little bit of structural failure to get the texture right.
Speaking of texture, let's talk about the Holy Grail. The crispy edge with the soft, chewy center. The paper calls it the ring effect. How do we engineer that?
You have to use the heat gradient to your advantage. Cookies bake from the outside in.
Okay.
So the edges, the ring, they're getting hit with radiation from the oven walls and, more importantly, conduction from the hot metal pan. They just heat up way faster.
So the edge of the cookie is living in a totally different climate than the center.
A completely different climate. The edges set and get rigid while the cinder is actually still expanding. But here's the tricky part, the Maillard reaction.
That's the browning, right? The toasty flavor.
Exactly. And it only happens effectively between, say, 105 and 120 degrees Celsius.
So the whole race is getting the center hot enough to taste good before the edges burn to a crisp.
The paper actually calls it the extinction phase.
The extinction phase. That's a very dramatic way of saying, I burnt my cookies.
It is. But it shows how you're trying to optimize all these variables at once. It's actually a lot like the kind of problems you see in, business workflows.
It's all about managing variables, isn't it?
That's the whole game.
It is. And, that brings us to our sponsor, Silk. If your business is trying to figure out where AI agents can have the most impact, or even for your personal life, you should check them out.
They do AI training, automation, software development, all that stuff to help you handle those complex variables.
They help you work smarter. You can find them at embersilk.com for all your AI needs.
So, back to the oven.
Yes, back to the oven. The practical takeaway. The study actually tested the real-world dial settings. They compared 185, 2055, and 225 degrees Celsius. What's the verdict?
Well, 185 was a failure. It's just too low.
Okay.
The moisture evaporates so slowly that the cookie dries out completely before that Maillard reaction really gets going. So you get that pale, dry texture you were talking
The
about.
sad Frisbee. Okay, so crank it up.
Not too far. At 225, it's too aggressive. You get this rapid expansion, but the edges hit that extinction phase. They burn way before the center has a chance to cook.
So 205 degrees Celsius is the Goldilocks zone.
That's what the data says. It balances the rate of expansion with the color development perfectly. It lets the center brown just as the edges are setting
You get that perfect contrast.
without the carbonization step.
It's fascinating that we can essentially engineer pleasure. We're using these invisible forces, thermodynamics, to perfect a simple joy like a cookie.
It really is a testament to our ingenuity, isn't it? The universe is just full of these solvable puzzles, and I love that we can use physics to make the world a little more delicious.
Well, if you enjoyed this deep dive, please make sure you subscribe to the show. And hey, leave us a 5-star review if you can. It really does help us find more of these puzzles to solve.
Thanks for tuning in.